This next section is section 11.5, Techniques for Finding Derivatives. Firstly, a notation for the derivative. All of these ways are ways to write the derivative of y equals f of x. You could say dy dx. You could say f prime of x. The prime is really important. You could just say y prime. The book also has a few other ones which are less used and frankly less important. Capital D sub x is another way to write derivative, and this one we hardly ever use in this class. Most of the time you're going to see these three notations here. The first rule that you have to memorize is the constant rule. If f of x equals k, where k is any real number, then f prime of x equals 0. You can tell this by the slope of the line, thinking of the slope of our function. Remember that a function that's constant is a horizontal line. This is f of x equals a constant. So like 6 or 2 or 3. What if it's 3? This is the line y equals 3. What's the slope of a horizontal line? It's 0. So if the slope is 0, the derivative everywhere is 0. The power rule. This is probably the most important rule that we have for a long time. If f of x equals x to the n power, where n is any number, then f prime of x is equal to n times x to the n minus 1. You take the exponent and pull it down in front, and then you subtract 1 from the exponent. Here's an example. F of x equals x to the 6th power. So if I want to take the derivative of this, all I have to do is pull the 6 down in front and subtract 1 from the exponent. That's it. It looks just like a game that we're playing with the numbers, and that's not a bad way to think of it. Constant times a function. In some books you also hear this called the constant multiple rule. If f of x equals a constant times a function g of x, then the derivative just leaves the constant right in front. The constant multiple does not affect the derivative. Here's an example. I'll do an example right over here. F of x equals 6x to the 3rd. The derivative is 6 times the derivative of x cubed, which is 3x squared. There's the power rule. Now we can simplify this by multiplying the 6 and the 3 and get 18x squared. Sum or difference rule. This is a good rule to know, but it's not that difficult to understand. If f of x equals two functions that are added or subtracted, then the derivative, you just take the derivative of everything you see. Then f prime of x equals u prime of x plus v prime of x. If f of x equals the subtraction, the difference, u of x minus v of x, then f prime of x equals u prime of x minus v prime of x. So an example, f of x equals x to the 4th plus 2x squared. You can take the derivative of the first one, that's the derivative of x to the 4th, that's the power rule, plus the constant multiple rule says the 2 just stays out there. The derivative of x squared is 2x to the 1st power. Now we need to simplify. 4x cubed plus 4x. And that's the derivative of that function. Here's some examples for your notes that may be helpful. Let's look at the first example. F of x equals 4x squared minus 3x plus 5. Take the derivative and let's see what happens. Constant multiple stays out front. Derivative of x squared is 2x to the 1st 3, constant multiple, stays out front. Derivative of x. Now, x is a kind of almost a special case. This is x to the first power, right? I pull the 1 down in front and subtract 1 from the exponent. I'll come back to that one. What's the derivative of a constant? Derivative of a constant, if you look back at our rule, is 0. Now, what's anything to the 0 power? Anything to the 0 power is 1. That's a rule of exponents that you need to know. Anything to the 0 power is 1. So the derivative of x to the first power is 1. This is another rule you should really memorize and not have to worry about. So our derivative of f prime of x equals 8x minus 3. Here's one where the exponents are fractions. Not a problem. The exponents can be anything we want. It's not going to affect how we do the problem. This exponent, the whole exponent, is a fraction, 3 halves. So I'm going to multiply by 3 halves in front and then subtract 1. Now be careful with fractions. Subtract 1, that's 2 halves, right? 3 halves minus 1 is 3 halves minus 2 halves. That's 1 half. Constant multiple, 4. I'm going to multiply by 1 half. T to the subtract 1 from 1 half. You may want to do this off to the side or use a calculator. It's negative 1 half. So y prime equals, this is 36 t to the 1 half plus 2 t to the negative 1 half. Now in calculus, if all I want is the derivative, this is okay to leave it like this. That's okay to leave the exponents as fractions and even negative exponents, because I'm not going to care that you need to simplify this. For some problems later on, we may need to simplify this, but we'll leave it right here for now. This looks much more complicated. Y equals 19 over the 4th root of x. And if you don't know your exponential rules, this is not going to be easy. Please notice, I am not taking the derivative. I am just rewriting the problem using exponents. The 4th root is the same thing as x to the 1/4. Now, it's on the bottom. I don't have a rule for what happens on the bottom. So I can rewrite it. This is the same thing. I'm not using the derivative. I'm going to rewrite it as x to the negative 1/4. Now, if you don't know those exponential rules, this gets really, really hard to do. So you have to know those exponential rules. The 4th root is 1/4 power. If it's on the bottom, you move it to the top and change the sign on the exponent. And now, I can take the derivative. The 19 stays there. The negative 1/4 comes down. X to the negative 5/4. Remember, I subtracted 1 from the exponent. Minus 4/4 is minus negative 1/4 minus 4/4 is negative 5/4. dy dx, negative 19 over 4, x to the negative 5/4. If it's your math teacher like me asking for a derivative, that's fine. If you look in the back of the book, they may have slightly different interpretation, but that's okay. It's the same thing. Don't worry about any of those. If that doesn't work, it's okay. I'm okay with this if all I want is a derivative. That's fine. A couple of word problem things that we need to talk about. So some applications for you. Applications like marginal cost, marginal revenue, and marginal profit. If c of x is the cost function, marginal cost is the derivative. Similarly, marginal revenue is r prime of x, and marginal profit is p prime of x. So here's an example. The revenue equation in hundreds of millions of dollars for barley production in the United States is approximated by this function r of x, where x is in hundreds of millions of bushels. The data comes from www.usda.gov. A. Find the marginal revenue function. Marginal revenue is r prime. This is r, so all they're asking is take the derivative of this function. So you take the derivative of this function exactly the same way you take the derivative of any other function. Part B, as I'm running out of time on my video, Part B is find the marginal revenue for the production of 500 million bushels. So once you've found r prime, you're going to plug in a value. Now be careful. This is 500 million. But what did they say about x? It said x is in hundreds of millions of bushels. So here, this is when x equals how many? Hundreds of millions. This is 500 million. So x is just 500 million bushels. So don't make it harder than it needs to be. Just plug in the value that they're asking you to plug in.